Traditional methods tend to involve quenching a well, bringing in a workover rig, and this can lead to the well being offline from production for 4 to 6 weeks.
Geothermal makes up about 20% in its total energy at the moment.
To look into methods of using coiled tubing to clean out the well in live conditions, so flowing the well to surface while cleaning it out, and thereby reducing the downtime and the risk to the asset. We developed a nitrogen-powered pneumatic hammer that mechanically removes the scale built up in the wellbore. We're now able to have the well back online at full production to the station in as little as 6 hours. I'm a father to 2 young kids. I want them to be proud of the work their dad's doing, supporting that transition to decarbonised future.
Welcome to Geothermal Unleashed, the podcast where we dive into the frontier of geothermal energy and its role in the global energy transition. I'm Elizabeth Cambry with the Valorec New Energies team, and I am here to help spotlight the innovators, technologies, and stories that are driving geothermal forward. Today, I am thrilled to welcome the Western Energy team joining us all the way from New Zealand. We have Tessa Williams, who is the Technical Project and Logistics Coordinator at Western Energy, Toby Ryan, who's the Technical Service Manager, and Ben Drew, the International Business Development Manager. To get things kicked off today, I would like to ask each of you to introduce yourselves. Tell us a little bit about your background, your career, your education, and how you came to be a part of the geothermal industry.
Yeah, thanks, Elizabeth. So I'm Toby Ryan. I'm the Technical Services Manager at Western Energy. I studied Chemical and Process Engineering at the University of Canterbury, graduated in about 2008. Following this, I moved to Perth in Western Australia in the hopes of finding a job. Unfortunately, late 2008 was a terrible time to be an inexperienced graduate looking for work, so I enrolled in a postgraduate diploma in oil and gas engineering at the University of Western Australia. Following my studies, I joined Schlumberger as a coiled tubing engineer. I spent 3 years with Schlumberger, most of this time in Russia, Southeast Asia, and then I moved into subsea engineering, working as a field operations engineer and project manager on major projects throughout Northern Europe and Equatorial Africa. I shifted into the geothermal space in late 2020 when my family and I moved home to New Zealand, and I joined Western Energy as a project engineer, primarily focused on coiled tubing interventions, before moving into my current role as the team manager in late 2023.
Wonderful. Thank you. And Tessa, how about yourself?
Hi, so I'm Tessa from Western Energy. I also studied at University of Canterbury, so I studied geology and then briefly worked in gold exploration in Australia. And then I lived overseas for a long time, but then found myself back in New Zealand and in Taupo in 2020 and kind of stumbled upon the geothermal industry and haven't looked back. Started my current role in the project coordinator role and have moved into sorting out a lot of our logistics for international operations, which is, it's turned out to be an amazing opportunity.
I love that. And Ben.
Hi, good morning, Elizabeth, or good afternoon for you. Thanks so much for having us. So my name's Ben. Slightly different start to the world to Toby and Tessa. I grew up in Eastern Australia, a Warwickle country, and finished high school there, moved to Sydney to study chemical engineering. And similar to Toby, when I finished university, there were sort of two main things going on. One was the global financial crisis had recently happened, and the second part of that was Australia, where I grew up, was going through a bit of a mining resources boom at that time. Sideline to that is that Al Gore's Inconvenient Truth had recently come out, and you were starting to see these shoots of people talking about renewable energy and things, and I had an interest in that, but there just weren't many opportunities at the time. So I ended up in resources, and was a great journey. For about 10 years, I was with a large oil and gas services company. I started originally in coiled tubing, like a lot of people do, as the field engineer, and then you move to be the technical sales engineer. Then I moved into the line management position. I spent a little bit of time in HR, and then finally moved into sort of my last role was in new technology implementation. During that time, I'd always still had this interest in renewable energy and decarbonisation. And the long story short, I ended up finding this, Western Energy, this small geothermally focused services company who had a coil tubing unit, which happened to be the sort of specialty that I'd had through my career so far. And in 2019, I moved over to New Zealand. I was living in the Middle East at the time and started as Western's first project engineer. Prior to that, Western was more just your traditional contractor services company where the client calls and you deliver a wireline survey or a coil tubing job. And we started to see some demand from clients to have more focus on planning and engineering and some technical thinking about their well maintenance in particular. So yeah, like I mentioned, I was the first project engineer, and now the team that Toby manages has about 8 engineers. So the business has continued to grow slowly, and that's been really great to see, and happy to be now in a different role. Western's sort of expanding internationally, and I'm managing the international growth and realizing some of those international well maintenance opportunities for Western.
Exciting. Well, we're going to talk about some of those opportunities today. But before we get there, let's start with a question for Toby. So, for our listeners who may not be familiar, can you explain what Western Energy is and the core services or solutions that Western Energy provides?
Yeah, so Western Energy is a small well services company based out of Taupo in New Zealand. Think like a very small Schlumberger or Halliburton in terms of oil and gas services companies. But what makes Western unique is that we are solely focused on the geothermal industry. We're a wholly owned subsidiary of Contact Energy, who are the largest geothermal operator in New Zealand. And we provide a range of services that support the full life cycle of the well, right from drilling through to permanent abandonment of the well. Our wireline team offers a full suite of logging services, including PTS surveys, caliper surveys, formation images, and camera runs. And our well intervention team provides coil tubing, pumping services, and this includes well initiation through gas lifts, wellbore scale workovers through our live well cleanouts, formation cleaning to clean the near wellbore scale, and more recently rigless casing repairs and coil tubing drilling using our high capacity coil tubing unit. Also, through our relationship with Contact Energy, we offer a whole raft of geothermal professional consulting to clients throughout the world through our partnership called Steam Team.
Interesting. So, do you think Western Energy is the only geothermal service company that's out there around the globe?
Fully geothermally focused, we believe so.
Very interesting. I love that. All right. So, let's talk a little bit about what geothermal energy looks like in New Zealand. Tessa, can you walk us through New Zealand's overall energy mix?
Yeah, so geothermal makes up about 20% of the total energy at the moment, and it basically acts as a base load. So we also have a lot of hydro, wind, and then a little bit of gas that's basically used as a peaker. But at the moment, the geothermal is about 20%. We have had days where the wind and solar has been a bit lower, and it's been up over 80% of the generation for that day, which is super cool. So the cool thing is the geothermal is located in the North Island in really close proximity to our largest city. So it's really well placed to distribute the energy around the North Island where most of the people are. At the moment, we have about 1,200 megawatts of installed capacity, and that's growing all the time. So we've already had about 100 megawatts come online just in 2026, and there's another 100 plus planned to be coming online throughout this year and into 2027 as well. So yeah, really cool time for geothermal. Lots happening.
Ben, let's talk about some of the challenges. Can you walk us through the biggest technical or operational challenges that are facing geothermal development and operations in New Zealand?
Yeah, sure. New Zealand has some of the same challenges that other geothermal markets have in terms of resource uncertainty. understanding the resource, re-injection complexity, and drilling costs, and keeping them down. I think the unique challenge that New Zealand has compared to other markets is making those resources sustainable over decades. So the Wairakei Power Station, which was New Zealand's first geothermal project, began in 1958, which was even just before the people think of, the geysers in the United States and how long that's been operating. And the Wairakei Power Station actually started operations before that. So maintaining that resource delivery over such a long period of time is a unique challenge that New Zealand's had, and doing that amongst the tight environmental and cultural boundaries within New Zealand. From Western's perspective, as a services company, we don't get to touch on, I think, the same challenges that operators do in New Zealand. But for us, the challenges we come to day are things like reservoir pressure decline and monitoring the reservoir, geochemistry problems like scaling, corrosion, management of non-compressible gases or NCGs. I think drilling cost is unfortunately something that continues to rise, and for a small island in the South Pacific, getting materials to do geothermal drilling is difficult, and costs go up. So trying to keep that down is really important. And operations and managing our operations without a strong local manufacturing base is also quite difficult, and that kind of comes into the maybe not as exciting, boring kind of logistics, and like we have experts like Tessa on our team to try and keep those costs down to really, Western, what we try to address for our customers is lowering that ongoing cost of generation. So not just keeping the capital costs for the project, the drilling costs and establishment costs down, but also making sure the life cycle costs of operating those geothermal plants and fields remains low, so the energy remains competitive. So I can stop there, or there's also some technology we've been working on to address those issues. So for the drilling costs, for example, Western bought a high capacity coil tubing unit, and we've been exploring using coil tubing drilling to try and reduce those drilling costs. So we think, pardon me, we think with the use of the high capacity coil, we can probably reduce the makeup drilling costs for operators in New Zealand by 30%. We've also been involved with quite a lot of modelling for well initiation to try and start the wells up. Some wells that require gas lift initiation, starting them in a way that protects the casing integrity is really important. For the mineral scaling, I think Toby's going to talk a bit about later with live well cleanouts and scale removal. Formation cleaning is another technology we've been developing to help lower the cost of generation. And then again, through the use of that high capacity coil, rigless casing repair, rigless workovers, and also lowering the final, I guess, part of the well life cycle, the abandonment cost, which since Western started, we've managed to halve the abandonment cost for geothermal wells in New Zealand, which is helping lower the cost of generation as well.
Very interesting. I'm just curious, are there a lot of wells that are in queue to be abandoned? I never thought about that before.
Yeah, I think not a lot. I guess, like I mentioned, the fields have been there for a long time. And part of one of the challenges I mentioned was the re-injection complexity. So it can be that different parts of the reservoir are producing cold downflows that are affecting production wells. So one technique could be to abandon the well to prevent that cold downflow getting to hotter parts of the reservoir. Another challenge is that, the wells have been there since, like I said, since the 1960s. So managing that casing integrity is important. So some of our customers have sort of regular abandonments they do from year to year, but I think it's quite regulated in New Zealand when wells need to be abandoned in the geothermal sector. So it's something. Yeah, it's a big difference actually we've noticed between working in New Zealand and other markets, is that there does seem to be a regular program in New Zealand to manage the well abandonment.
Interesting. All right.
There's also,
Well,
sorry, Elizabeth,
yeah,
there's also a financial requirement from our clients to hold basically a contingency to abandon a certain portion of their wells. So it's from a financial perspective, it's in their interest to permanently abandon the wells that are
yeah.
either high risk or no longer commercially productive.
Well, that makes sense. It's clear that New Zealand has a long history with geothermal. Tessa, why don't you talk a little bit about what makes New Zealand's geothermal resource unique compared to other regions globally?
Yeah, absolutely. So we're actually basically super lucky in New Zealand, and that's how we've come to have such a really great geothermal resource. So it's a really hot, shallow reservoir with great permeability. So the main area for geothermal generation is where we are. It's called the Taupo volcanic zone around Taupo, and then it also spreads up to Kawerau in the east. I think I sent a graphic, Elizabeth, sorry, off script, but it would be great to put that in. So up to Kawerau, and then there's also another area up in Northland called Nafa. So yeah, really hot, shallow with good permeability, which is a great starting place. It's also really easy to access. So where we are in Taupo, our steam fields are basically flat. So in terms of the physical logistics of drilling, servicing, building a power station, we're not kind of on the side of a mountain in a jungle like a lot of our counterparts in Asia. We're also really lucky that our reservoirs are really benign compared to other places as well. So we don't have problems with acidity in our fluid, which is great. And something kind of unique is that it's really high enthalpy two-phase flow. So we operate binary plants mostly here, and we actually had the world's first liquid dominated station. So yeah, pretty great resource for us to utilize, and using some of our Kiwi technology, we've basically just been able to make the most of it, which has been really cool for the industry.
Toby, I would love for you to talk a little bit about Western Energy's solution for cleaning out live geothermal wells and why this capability is so important for your customers.
Yeah. As I'm sure every operator knows, wellbore scaling is a enormous problem in geothermal wells, and traditional methods tend to involve quenching a well, bringing in a workover rig, and this can lead to the well being offline from production for 4 to 6 weeks. It also introduces the risks associated with thermal cycling of the well casing. So starting in around about 2016, Western partnered with Contact Energy and 2 other local New Zealand companies, General Compression and Anchorlock, to look into methods of using coiled tubing to clean out the well in live conditions, so flowing the well to surface while cleaning it out, and thereby reducing the downtime and the risk to the asset. After multiple iterations, we developed a nitrogen-powered pneumatic hammer deployed on coil tubing that mechanically removes the scale built up in the wellbore and up to about 99% of the original casing ID. Nitrogen pneumatic hammers are a fairly common tooling in oil and gas, but we had to adapt and improve that technology to have it suitable for the geothermal conditions, namely the temperatures and pressures that we're experiencing downhole. There's multiple benefits to operators of our live well cleanout method, namely the reduced downtime of the wells during the cleanout, less risk to casing integrity by removing that need to thermally cycle the well with quenching, and performing the clean out live means that the natural flow of the well carries the scale debris to surface and completely removes it from the wellbore system. And over the space of the last 10 years, this technology has gone from highly experimental to a key weapon in the arsenal of our clients' fueling teams when it comes to routine maintenance of their wells. So whereas previously scale cleanouts would take their wells offline for up to 6 weeks, we're now able to have the well back online at full production to the station in as little as 6 hours.
I'm curious, how often when you're monitoring a well, would you have to end up going in and cleaning out the wells?
Each well's different, and we sort of have a group of wells that we're probably cleaning out in the space as regularly as every 12 months. Our client's fueling team sort of keeps an eye on the wells and juggles the current power price with the well decline, and they might think, well, in 3 months' time, the power price is going to be much higher, and so taking the well offline at that stage would be more expensive. So let's perform the clean out after 9 months rather than 12. So yeah, there's it's become routine maintenance for a number of wells. Other wells that don't have the scaling issue as much, we might go in there sort of every 2 or 3 years.
Interesting. So, Toby, what are the key technical or safety challenges when working on a live geothermal well versus one that's shut in?
Yeah, so from a safety perspective, the main challenge is well control. So this is a live well producing several hundred tonne an hour of steam and brine. So ensuring the integrity of our well control system is the paramount focus for the operational team. In terms of operational challenges, the main one is that we are relying on the well flow to transport the scale cuttings to surface. We're running, like I said before, about a 99% drift inside the casing. So if we're not removing the scale to surface efficiently, we run the risk of packing off the tooling and getting stuck down a hole. So it's really important to understand the well flow, which feed zones are contributing to this. And so therefore we can assess the carrying capacity of the flow at any given point as we progress down the well and avoid getting the tool packed off. The hammer doesn't have rotation. It doesn't turn like a traditional bit on the end of a motor. It's very, very, very good at going down, but if we do get stuck, it's got limited options to pull out. So one of the issues we've found is that in some cases, our tool can almost be too effective at cleaning out scale. So we often have to limit our rate of penetration, our ROP, to ensure that the scale is fully pulverized into almost like a sand rather than broken off into chunks the size of a knuckle that may not get carried up to the surface and therefore risk packing off the tool.
Then, can you walk us through how Western Energy's approach or technology differs from more traditional oil and gas well service companies?
Yeah, definitely. Starting with the approach, so Western, we have about 40 people in our organisation. We're a small business, and so we need to remain really client focused. That's one of our values, deeply engage with our customers. So our approach is very client focused and very problem focused rather than, you might say, technology or product focused. So rather than saying, hey, we have a hammer, come and use it, we'd like to engage with our customers and try and find data-driven solutions to the challenges and problems they're having, and which is mostly lowering their well maintenance. So our approach often involves asking for more well data and doing what we call like a well triage, kind of like how a doctor might diagnose a patient for a condition. We're using the well response and the well characteristics to put together a plan to clean that well and what technology to use. And that's all about de-risking the process for the operator. It's probably known to most of your listeners that the geothermal maintenance budgets are less than oil and gas or other industries. So trying to manage that amongst the other challenges of high temperatures and large casing sizes. So we often recommend a lot of well diagnostics even before we go and do any kind of clean out or workover or intervention. So that could be different wireline works or sampling or testing of the well to ensure we've got all the right data to do that well triage properly and come up with a great solution. So we've just talked about the approach, very client focused. From the technology point of view, I guess there's some maybe somewhat obvious aspects of the technology we use that needs to be rated for high temperatures because the wells are hot. So our production logging tools, are rated to 315 degrees for 6 hours or about 300 degrees for 4 hours. That we always trying to remove more leak points and elastomers. Rubber doesn't go so well at 300 and above 300 degrees. So trying to find metal seals and ways of making these tools robust for large casing sizes. The geometry of the geothermal, at least the hydrothermal wells that we work on in New Zealand, is they have a sort of cased upper section and then a slotted liner lower section, and that transition from the cased upper section to the slotted liner lower section has a top of liner. So ensuring our tools are designed to, I guess, make that transition from the larger casing to the slightly smaller liner and pass through that without damaging the liner, getting stuck, like Toby had mentioned, or getting stuck within the liner. That's really important. And like I'd mentioned, keeping the cost down, keeping the low cost for our clients to have that well monitoring data more regularly is more valuable than doing, one survey every 12 months. So trying to work on the commercials so that they can run these tools more regularly rather than once every now and again. So some of the specific technology we use, some of your listeners might have heard of like gauge rings, which is your probably most basic well access tool. So it's some kind of tool of a certain diameter, you run it in the well, it'll run into something, and then you pull it to surface and there's an obstruction there. The high end of that would be like a multi-finger caliper with 40 arms that can go down and map the entire ID of the wellbore. For a place like New Zealand, like we mentioned, which is far away, getting a tool like that into the country comes at an expense. So Western's sort of got a product in between that, which is called a XY caliper. And there's a couple of providers for that in the market. Probe, Caldera, we work with as well. And that provides like a 2-armed caliper. So you can get a full, 2D view of the well of where the scale is. And why is that useful then? So when we're doing the well analysis for the customer, if we can see that the scale's only in the upper part of the wellbore, there's no reason to take the coil tubing down to the lower part of the wellbore. So the job's done faster, takes less time, there's less risk of getting stuck because you're in the well less and things like that. We also have like geothermal scale mills. I think on some of the other episodes, some of your guests have talked about what Fervo have been doing in terms of drilling bits, but for cleaning scale in wells, it's slightly different. So we've helped develop, where to put the gauge protection on the bit for cleaning scale from wells, because in the liner section, the cutters can chip off in the liner. So we've helped redesign some of those PDC bits for scale cleaning. Like Toby mentioned, the well control management is really important. So we don't have BOPs that are rated to 300 degrees for the steam coming out. We have cooling systems that help maintain the BOPs within their working temperature. So not necessarily new technology, but it is the know-how to be able to manage that equipment. Then we talked about abandonments briefly before. We have a cement lab, our own cement lab in Taupo, and designing slurries that can be suitable for those geothermal conditions. That maybe the circulating temperature is 160 degrees, 160 degrees Celsius, so probably 320 plus Fahrenheit. So designing those slurries and making them specific to the geothermal environment is really important. We also have done I wish I had the pictures to show. There's some small monitoring wells in the geothermal environment of the Taupo volcanic zone. We found ones on golf courses. Well, not found, they know they're there. Wells on golf courses, wells in public parks. I'm trying to think, Toby, of the other one. They're monitored for monitoring purposes. And because the steam field's changed since the 1960s, these wells are in places where it's hard to get a coil tubing unit in. So we've helped. For example, our wireline unit can also run 3/4 inch OD coiled tubing, and we've used that unit to be able to abandon some of those old wells or do monitoring on those wells. Also, things like swaging and broaching are really important. So developing different broaches to help remove scale from the geothermal wells. And the most recent, technologies that we've been implementing is like the coil tubing drilling and large high capacity coil workovers. So being able to go in and mill out a casing obstruction with coil tubing, run a new casing string, cement it in place, and then that well has a birthday, essentially, is in a great new condition to continue doing its job. Some of them. I think that's probably enough. I could talk about it all day, so I'll leave you with that.
I was really curious.
Just jump in there.
Go ahead.
We'll try to dig out a photo, but what Ben was talking about there on those these little wells that are all over this place, we had to abandon a well that was on the T off point of the 18th hole of one of New Zealand's most prestigious golf courses. And so it was a real struggle to get big heavy truck equipment into that when you got pristine lawns and famous New Zealanders waiting for a tee off.
And protected wildlife.
And protected, endangered species. Yes.
I'm just
We'll
curious.
try some photos.
I'm curious, do you think anyone else around the globe is doing live well cleanouts, or is this something that is unique that Western Energy is providing and doing in only New Zealand?
There are some other groups of people. I mean, for example, in the US, there was some papers coming out of Circ Energy, I believe. They've been doing some live well cleanouts. I would say Western's the only place doing it so reliably with like a percussive hammer tool. The paper Circ put out was more focused on mud motors, and that seems to be working really well for them. We definitely hear whispers of other places around the world or other companies trying to replicate the technique, but we don't see a lot of literature in the market, or at least at geothermal conferences, especially related to the pneumatic hammer.
Okay, so it's safe to say that Western Energy is leading the pack with live well cleanouts and monitoring.
Yeah, we like to think so.
I love it. I mean, it sounds like it. All right, let's turn to what I think is an exciting topic. Tessa, I would love for you to touch on whether there's any opportunities for enhanced geothermal systems in New Zealand, or is New Zealand primarily going to be focused on conventional geothermal resources?
Yeah, so I think everyone's probably getting the point so far that the thing about the New Zealand system is that it's really hot and reasonably easy to access. So for context, the temperatures Ben is talking about, that's all in degrees Celsius as well. So we're pretty lucky that we've got like some of the wells at our original station Waira here are only about 800 meters steep. So it's pretty common to have over 230 degrees Celsius, which is almost 400 Fahrenheit at 1,500 to 2,000 meters. So we're basically super lucky to have a really, really strong, consistent, conventional geothermal system here. So there's definitely interest in EGS, and it's definitely something that the operators here are pretty open to new opportunities. It's definitely something that's on the radar. Maybe something at the periphery of existing systems, or something that we could look at developing in new areas that are like kind of more marginal for the conventional. But the really exciting thing in New Zealand at the moment, and the big focus for development, especially from the government perspective, is supercritical. So talking about drilling down to 5,000 meters and finding temperatures kind of up to that 300 to 500 degrees Celsius in the kind of magma transition zone. So that's kind of the thing at the moment that everyone is kind of focusing on and gearing up for, and that has a lot of investment focus from the government at the moment. So in New Zealand, we love to be open to new opportunities, and all of the operators are definitely looking for the next new thing, and there's definitely interest in EGS. But I think at the moment we're so lucky with our conventional resource, and then the potential for supercritical is so huge that that's where it's kind of headed at the moment.
Toby, I always like to ask this question to different people to hear their perspectives on how transferable skills are from oil and gas to geothermal.
Hugely transferable. Both Ben and myself come from oil and gas backgrounds, and you just need to look around the yard of Western Energy. Of the 30 or so engineers and operations staff, at least half of them have transferred over from the major oil and gas services companies. It's at the end of the day, we're still putting holes in the ground, we're still bringing the energy up, and we need to put the holes in the ground to begin with, and we need to service and maintain those wells. It's quite complementary skill sets. We're just dealing with much higher temperatures and much larger wellbores. Technology is also massively transferable. Given the size and the value of the oil and gas industry, there's obviously been far more spent there in terms of research and development of new technology compared to the geothermal industry. So we're constantly looking over the fence into the oil and gas space to see what's been developed, assessing what we can pick up and what we can adapt to suit the conditions that we're dealing with.
Ben, at the beginning of our conversation today, you mentioned that Western Energy is expanding outside of New Zealand. I would love to hear more about the regions that Western Energy is targeting.
Definitely, I'd love to talk about that. I guess the background is even indirectly, Western and other New Zealand companies have been exporting their geothermal expertise for some time, and New Zealand being the small geothermal powerhouse that it is, we often talk about this idea of New Zealand Incorporated, where other small New Zealand companies with their niche sort of partner together and work together overseas. So, for example, I'm getting to the question, but this is just setting up for the answer. So, for example, the University of Auckland has a program they call the Geothermal Institute. So there's a lot of, I guess, Western's now customers have studied at that Geothermal Institute and gone back to their respective countries, not only with the knowledge of the New Zealand geothermal market and systems, but also the companies that operate here and how we do things. And Western Energy has found that seeking out those previous connections is really important. So we have worked, to get to the question, we have worked in the United States, in Guatemala, and we've done some consulting in Japan, in Ethiopia as well. But we've found the most work for us is in the Philippines, and that's where we've been exporting most of our services internationally. We've had interest from Indonesia as well, and we get a lot of different consulting opportunities, but Philippines has definitely been where our services have stuck the most. Why that's the case, like I mentioned, I think there's strong cultural ties between New Zealand and the Philippines, and especially within geothermal with the education part that's gone on here in New Zealand and exporting that there already. I think they also have quite a lot of scaling problems in their fields over there, which tend towards solutions like live well workover that Toby's been talking about, pneumatic hammers, mud motors. They also have well-established fields. Their fields are really mature, although there is some new drilling going on in the last couple of years. Their fields have been there a while, so that idea of lowering the cost of production very much mirrors what Western has going on. I think another key part too is the smaller oil and gas presence in the Philippines. So in New Zealand, there is an oil and gas industry as well. Geographically, it's quite separate from where the geothermal fields are. So, for example, in New Zealand, that's sort of 4 or 5 hours drive in a car between those two fields. And some people might say, oh, that's not very far at all. But if you're a small wireline company trying to run surveys every day, being 5 hours away is quite commercially prohibitive to being part of the market. And conversely for us, for Western to go down into the oil and gas market, we've got this 4 or 5 hours mobilization to do. And similarly in the Philippines, for oil and gas service companies, they really need to invest to bring in equipment to be able to access those clients. And when you have other oil and gas opportunities knocking on the door, it may not, opportunities like that may not be as high. But for a small geothermally focused well services company, a place like Philippines with a low oil and gas presence, mature fields, scaling problems, known production decline, not to mention things like the time zone. Like the time zone's only kind of 4 hours different, 4 or 5 hours different to New Zealand. So that makes it easier to work in. There's, you can see some similarities, say, between New Zealand and Iceland, but the time difference just makes things like a little bit more prohibitive to try and engage there. Other markets we're looking to expand into, we've done some work recently in Japan. Similarly to Philippines, low oil and gas presence, has had training links to New Zealand for some time. liquid-dominated reservoirs similar to Wairaki, which we mentioned before, known scaling problems. I guess different to the Philippines, maybe more predictable business environment, but each of these geographies has their own pros and cons, you could say. But they're the key markets we've been trying to go into lately, Philippines and Japan.
Tessa, what are the biggest challenges when you're deploying crews, equipment, and technology internationally from New Zealand?
Yeah, so like Ben has said, we're super lucky to have a great demand for our project approach and technology in these new markets for us, which is amazing. But there are definitely challenges associated with being 40 people in New Zealand trying to operate in the overseas market. So like Ben mentioned, the time zone with the Philippines is pretty accessible. But what we found on our last campaign is that the time difference between the USA, where most of our tools are eventually sourced from, and the Philippines is only 1 or 2 working hours a day. So there's definitely some, on a practical logistics scale, some of the challenges between getting the equipment from our suppliers, which are mainly in Canada and the US, and then coordinating that from New Zealand to the Philippines can be a little bit hectic at times. But that's fun. That's all part of the challenge. We love it. But yeah, so in terms of like achieving all of that on a one-off basis, it's definitely doable, but we like to focus on building those long-term relationships so that in terms of setting up all of that equipment and establishing a presence in country, like the more frequently we can work with those clients and the better relationships we can build, that's going to make it a lot easier for us long-term. So yeah, there's definitely challenges, but we thrive on the challenge, and the focus on building those relationships really helps us to gain efficiencies in the way we work and the way we can have our equipment and set up our supply chain for future success.
Toby, I probably should have asked this earlier, but I am interested to understand, what does the oil and gas sector look like in New Zealand, and how does it compare to the geothermal sector?
Yeah, it's quite an interesting contrast between the two industries here in New Zealand. Historically, the New Zealand oil and gas industry stems back to probably the mid 19th century, but really came into its own in the mid 20th century when major discoveries like Kapuni and Maui were discovered, and these two fields really underpinned the industrial development and our electrical generation for decades. Geothermal, on the other hand, similarly came into being in the mid 1950s with the development of the Wairaki station just up the road. As Ben mentioned, one of the first large-scale geothermal plants in the world. And from early on, even though geothermal was quite boutique industry in New Zealand, from early on, New Zealand was recognised as a global pioneer in the geothermal technology and reservoir management. In terms of maturity, the oil and gas industry here is mature in the traditional extractive sense. It's got established infrastructure, it's got really well understood basins, and it's got a relatively long production history. But it's also somewhat declining. It's declining domestically. As Ben mentioned, the production is concentrated in one small region called the Taranaki. The reservoirs are depleting, and investments being volatile, I guess. That's partly due to policy changes of different governments, and partly just because we don't have the scale of resources that you see in major oil and gas regions. Geothermal is also highly mature technically. As I said, New Zealand has long been considered a global leader, but it's not declining at all. In fact, it's still growing and evolving. As Tessa pointed out, the geothermal produces about a fifth of New Zealand's electricity, making it one of the country's largest and most reliable energy sources. But what's unique with the geothermal industry is that it's transitioned from early on being government-led industry into a sophisticated, commercially competitive sector that's got strong ties to local Māori and iwi, and they're having their participation, and also having long-term resource management. In terms of size, I guess depends on how you measure it. Economically, oil and gas has always been a high-value sector. It still generates something in the order of a couple of billion New Zealand dollars annually, but it employs relatively few people, and as I said, it's quite concentrated. Geothermal, by contrast, in terms of direct revenue, it's much smaller, but it's far more embedded in the national energy system these days. It underpins the baseload electricity, it supports industrial heat use, and is playing a critical role in the country's decarbonisation journey.
Do you think there's more individuals working in geothermal in New Zealand than in oil and gas?
I'm honestly not sure. Yeah, we're probably spread across a larger area, from Taupo up through Rotorua up to Kawerau, but in terms of the actual employment size within each industry, I'm not sure.
Interesting. Well, my final question for everyone today, and I want to hear from each of you. So looking ahead, what excites you most about the future of geothermal energy and Western Energy's role in the global energy transition? Toby, why don't we start with you?
Yeah, from me, I've been thinking about this question. I think from my perspective, it's more of a personal thing. Like I'm a father to two young kids, and I want them to be proud of the work their dad's doing. And being heavily involved in the geothermal industry and supporting that transition to a decarbonised future is something that really drives me in my work.
I love that. And Tessa?
Yeah, I think everything we've talked about today, like there's so much exciting technology. Western is such a great place to be working. We are in such a good spot going forward. We know that whichever direction this industry goes in New Zealand, geothermal is going to be a really important part of the transition, and Western Energy is going to be playing a key role in whatever that future looks like. So yeah, it's great. It's a really awesome spot to be in.
Thank you. And Ben?
Tessa covered most of sort of how exciting the future looks in geothermal. For me, I am very interested in the new technology in terms of we talked about EGS only briefly, supercritical, even ground source heat pumps. There's, I think, just for the New Zealand geothermal industry, it's always been this hydrothermal focus, and I think given what's going on in the rest of the world, there's lots of opportunities there that could be used in New Zealand as well. I think Western is very well positioned as a geothermally focused service company to take advantage of that. And I think, we haven't really talked about operations so much. We've talked a lot about commercials and where the business is heading. But if you ever get a chance to visit Elizabeth, the culture at Western is especially around safety culture and a work-life balance, and ensuring that our employees, like Toby mentioned, are proud of what they do, and the potential of sharing that culture with other operators around the world is something that really excites me personally, because Western's culture is very much built on, and a lot of companies talk about having a no blame culture and safety focused, and I would say from the places I've worked, which was a large oil and gas services provider, to Western Energy, Western really lives and breathes that culture and putting safety first. And we have a growing your whānau policy for parental support and parental leave, and I think sharing that kind of no blame culture, continuous improvement, and trying to drive the industry forward is a culture that I'm looking forward to sharing with the rest of the geothermal world.
Well, thank you everybody for joining us on this episode of Geothermal Unleashed. I hope today's conversation with Tessa, Toby, and Ben has offered fresh insights and sparked new ideas about the future of geothermal energy. Until next time, keep challenging assumptions, exploring new frontiers, and working together to unlock the full potential of geothermal energy.